So, what we talked about today was that in a linear equation, right, solution to that equation are points that are on the line. Any point on the line that you pick would make this particular equation true. Right, so just as an example, let's pick this point, which clearly is not on the line. So the x value is 10, the y value is 10. Let's sub that in. So we get it's 3 times instead of x, I'm going to put 10, plus 2 times instead of y, I'm going to put 10, equals 24. 3 times 10 is 30, plus 2 times 10, which is 20, and that's clearly not equal to 24. Right, so, which also tells you that this is not on the line and doesn't have the relationship between the y and the x values. 10 and negative 3, let's try that one. This is the x coordinate, the y coordinates. What's the equation? 3x plus 2y equals 24. So we're going to go 3 times 10 plus 2 times negative 3 equals 24. 3 times 10 is 30. 2 and negative 3, 2 times negative 3 is negative 6. And 30 minus 6 is 24 and equals 24. And that obviously worked. So that's pretty much what we were working on today. A little bit tedious, but the first question is the same. So here's my equation. 2x plus 3y equals 6. When you don't have a graph, you actually have to plug it in and substitute. So let's try 0 and 2. So again, it helps that you always identify who your x value and your y value. X is always the first in the order pair, and then y is the second. So 0 and 2, so we get 2 times 0 plus 3 times 2 equals 6. 2 times 0 is 0. 3 times 2 is 6, and these are definitely equal to each other, so A works. Let's try B. B is 0 and 6, so again x and y. 2 times 0 plus 3 times 6 equals 6. So 2 times 0 is 0, 3 times 6 is 18, and this is definitely not equal, so this does not work. C, 2 and 3. So x and y. 2 times 2 plus 3 times 3 equals 6. Does not, because that's 4, and this is 12, so you can clearly see that this is not a solution to that equation. Let's try D. D is 2 times 3 plus 3 times negative 2. And let's see if that equals 6. It's not, because it's going to be 6 minus 6, which definitely doesn't equal 6, because that's 0. So this is also, this one also doesn't work. 3 and 0. This one looks like it's going to work. X and y, so it's 2 times 3 plus 3 times 0 equals 6. 2 and 3 is 6. 3 times 0 is 0. That's definitely equal to each other, so this one is on the line. And the last one, x is your 6 is your x value, negative 2 is your y value. So 2 times 6 plus 3 times negative 2. 2 times 6 is 12. 3 times negative 2 is 6. Negative 6, I'm sorry. And if you subtract those two, look at that. So this one actually works out. It's much easier on the graph because you don't have to do all that. So we have 2 points, negative 4 and 1, which is negative 4 and positive 1 right here. And the other points 4 and 6, 4 and 6 right here. Let me, as best as I can, put a point through these. Oops, definitely not that one. Let me just drag it. And there we nope. Come on. Almost. That's better. So let's plot 0, 0.0 and 3.5. 0 and 3.5. 1, 2, 3.5. This point right here. It's on the line, so that's a good one. 8 and 5. 8 to the right and 5 up, which is right here. That's not on the line, so that wouldn't be a solution. 12 and 11. Why did they give us 12 and 11? I'll leave that for later. Negative 6 and 0. So 6 to the right. 1, 2, yeah. 1, 2, 3, 4, 5, 6. Negative 6 is 0. It doesn't look like it's on the line. 5 and 6. 5 to the right and 6 up. 1, 2, 3, 4, 5, 6. Also doesn't look like it's up, so that's not on the point. So 12 and 11. Now, obviously looking at the graph didn't help, right? Because 12 is out of our, out of range in our coordinate plane. So we're going to have to do a little work here. Negative 4 and 4, negative 4 and 1, 4 and 6. Let's find the slope. So negative 4 and 1, and the other one's 4 and 6. From 1 to 6 is positive 5 plus 5. From negative 4 to 4 is plus 8. So our slope, so think about what our slope is. Our slope is negative 4 and 1 and 4 and 6. So you can create a slope triangle. So basically we're measuring, right, we're comparing the height. And 1, 2, 3, 4, 5, we knew that from here. And the base, right, the difference in x value, it's 1, 2, 3, 4, 5, 6, 7, 8. And we knew that because of this. So the slope is a change in y, which was 5, over the change in x, which was 8. So our equation is y equals mx plus b. Y equals dm is 5 over 8x. I can't tell what the y-intercept is. So I'm going to leave plus b. So we're going to have to do that extra work we did today. Let me just move this guy over here. Let's pick a point, right, because I want to find b. So I'm going to use either negative 4 and 1 or 4 and 6. I choose to use 4 and 6. So I'm going to use 4 and 6 and replace the x and the y value with 4 and 6. And then I'm going to find the y-intercept. So I get 6. Remember, this is the x and y. So 6 equals 5 over 8 times 4 plus b. 6 equals, this is 1, 2. 5 over 2 is 2.5 plus b. Right? Subtract 2.5 from both sides. And b equals 6 minus 2.5 is 3.5. So that's my y-intercept. And look, we were very close, 3.5. So my full equation is y equals 5 over 8x, my slope, plus 3.5, my y-intercept. So now that I have my equation, I can plug 12 and 11 and see if it works. And if it does work, then I know 12 and 11, which is somewhere over here, is on the line. So take that, let's plug it in. I'm going to take the point 12 and 11, and then we replace the x with 12 and the y with 11, right? So 12 and 11. The 12 represents the x, the 11 the y, so we get 11 equals 5 over 8 times 12 plus 3.5. 11 equals 5 over 8 times 12, let's see, divide by 2, divide by 4, I get 3. I get 2 over 5. Sorry. So 5 over 2 is the same thing as 2.5, and 2.5 plus 3 is 5.5. And if I add that to 3.5, will that equal to 11? No, it won't. So 5.5 plus 3.5 is equal to 10, and notice that that point 12, 11 does not satisfy this equation, so that tells me that the point 12, 11, let me take it out of here, it's not on the graph. It's not on the line. Okay. Match each equation with its solution. Ooh. Alright, so let's look at this. Let's see if we can cheat our way so we don't have to do too much work. Let's see. Let's take an easy one. Here. Y equals 1.5x. So meaning, if I create a table for this, so remember when we created a table, here's my x value, this is my y value, this is my order pair. here was my rule. In this case, it's 1.5x. So let's pick x equals 1. So when x equals 1, we have to multiply by 1.5, and y equals 1.5. So when x equals 2, we multiply x times 1.5, and we get, oops, what am I doing? When x equals 2, we're going to take 1.5 and multiply by 2, right? And 1.5 times 2 is 3. Is there anything that looks like that? Now, look here. 2 and 3, right? Let's try 8. When x equals 8, I'm going to take 1.5 and multiply by 8. And 1.5 times 8 is 12, so that works as well. So we just found this guy right here. This one is E. Let's do some with zeros. That's another easy one. So pick this one right here. Let's pick this point. X equals 0, right? We're going to replace x with 0. And y was negative 4. X and y. So let's take 1 here. So for example, on the first one, 2x plus 3y equals 7. If I replace x with 0, and then I replace the y with negative 4, you can clearly tell that that's not going to equal to 7. So A is out. B, if I replace x with 0, 3 times 0 equals, and the y is negative 4 over 2, you can clearly tell that that doesn't work. So -0, -4 didn't work for equation A, didn't work for equation B. So let's see if it works for equation C. Sorry, I mean D. Sorry, I meant C. So x minus y equals 4. So let's put in this number. X is 0 minus y is negative 4. Does that equal to 4? Yes, it does, because negative and a negative is a positive, and 4 equals 4. So trying that point, it worked out that it worked for equation C, so that goes in there. Let's pick something else that's easy to substitute. Anything with a 0 here. The next one, 3.5 and 0. So this is gone, so I'm going to take this guy out, and this guy is out. Let's see where this would work. Let's try equation A. 2x plus 3y equals 7. And I'm going to try the point 3.5, 0. So this is my x value, my y value. 3.5, so 2 times 3.5 plus 3, and the y value is 0 equals 7. That seems to be true because 3 times 0 is 0, so that goes away. And what's 2 times 3.5? Equals 7. So this point satisfied this equation just fine. That's gone. So let's pick another point that has a 0. Let's try this one. 0.5. That's not another easy point. Just try this point 1 and 6. The point 1 is point 1 and 6. Let's try it in equation B, which is 3 times x equals y over 2. 0x and a y. So let's replace x with 1. So we got 3 times 1. Let's replace y with 6. We get 6 over 2. And look at that. They're equal to each other. So this point right here satisfied equation B. And obviously, the last one, D, will be here. And we don't even have to do that. Determine if the following statement is true or false. Plenty of thinking. The order pairs all lie on the line whose equation is that. So let's actually for this one. So remember when we created a table? I don't know how many of you remember. We can create a table. And this is the y coordinate. And this This is the ordered pair. This is what's happening to x, the rule. So for every x value, you're going to multiply by 4/3, right? And then you're going to add 5. So let's take the first pair, 6. When x is 6, y should be 13. So let's see if that's true. So we're going to take 4/3, multiply by 6, and add 5. So sorry, let me remove that because proof. 4/3 times 6, right? 1, 2. 4 times 2 is 8. 8 plus 5 is 13. Look at that. This one works. Second one, when x is 21, is y really 33? Well, 4/3 times 21 plus 5. 21 divided by 3 is 7. 7 times 4 is 28. And 28 plus 5 is 33. So the second also is confirmed to work. So this one works. Next, last one. When x is 99, is y really 137? So let's do it. It'll be 4/3 times 99 plus 5. It says 4, so there's a couple of things you can do. You can multiply 4 times 9 and then divide by 3, or you can divide 99 divided by 3 and then multiply by 4, or you can put this in the calculator. I'm going to do 99 divided by 3, which is 33. And I'm going to take that and multiply by 4, which is 132. And then I'm going to add 132 to 5, and I get 137. So when x is 99, is y really 137? It is. So all these points are on the line. Hey, how nice. Here's a linear. Oh my God. So again, right. So here's what I'm going to do. I'm going to change this. I'm going to write y equals 0.25x. I'm going to change it to a decimal. Plus 1.2. So only because see these points, they're in decimals. There's no point of having decimals and fractions. So I'm going to change everything to decimals. If you want to change everything to fractions, you can do that. I chose to change everything to decimals. So instead of 1/4, I did 0.25. Instead of 5/4, I did 1 point. Sorry, I forgot the 5. 1.25. So let's try this point. X and y. So every time I see x, I'm going to replace it with 1, and every time I see y, I'm going to replace it with 1.5. So here we go. 1.5 equals 0.25 times 1 plus 1.25. 1.5 equals 25 cents times 1 is 25 cents. And then plus 1.25. So it's 25 cents times $1 plus $1.25, $1.50. Yes, it is. Does that equal to the other $1.50 on the side? Yes, it does. So this one is good. Second one. X is 12, y is 4. Something tells me that that's not going to work. Y equals, so instead of y, we're going to put 4. And we're going to go 0.25 times 12 plus 1.25. 4 equals, so 0.25 is a quarter. What's a quarter of 12? A quarter of 12, right, or 1/4 of 12 is 3. I'm going to add 125 to it. And you can tell that this is not true because 3 plus 1.25 is 4.25, and they're not equal to each other. So this one is a no, it's not on the line. Alright, so this one we have to just plug it in, right, and solve. So let's try the first one. Y equals 2/3 x. And they're saying that x is -3. So wherever you see, I'm going to change this to -3. So y equals 2/3 times -3 becomes -1. Y equals -2. So here. Same thing, but instead of y now, they're telling us, instead of x, they're telling us that y equals 2. So I'm going to come here and write y equals 2. Let me figure out what x is. 2/3 x. How do we make that look like this? It's the inverse operation, right? So divide both sides by 2/3, divide this by 2/3, divide this by 2/3, right? So this 2/3 divided by 2/3 is 1. 1 times x is x, and 2 divided by 2/3 is actually 2 times 3 over 2, the reciprocal of 2/3, and that equals to 3, and that's your answer. Same thing for the other one. Here's the equation. Something plus something equals 5. When one of those somethings, in this case x, is -3, what is the value of y? That's what the question is asking. So, y minus so ugly. Y minus -3 equals 5. We do plus 3 here, and y equals 8. So this one, in order for that statement to be true, x needs to be -3 and y needs to be 8. All right, so what happens when the y value is 2? So when this guy is 2, what should x be? Well, 2 plus something is 5, and obviously that something is true. Is 3. That subtracts to 0. X comes down. 5 minus 2 is 3. So there. This table represents a linear relationship. Write an equation of form blah 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 blah. Okay. So let's pick 2 points. Pick 2 points. Doesn't matter. Let's pick these 2. From this to this is -5. From this to this, from 2 to 4, is +2. But to find the slope, it's the change in y, right? Over the change in x. Y is -5. The difference between these two values is -5. And the difference between these two is +2. So the slope, and we're going to leave it as -5/2. So if you go to your equation, right, we got y equals mx plus b. We can replace the m with -5/2 x, but we still need the b. How do we find a b? Well, now the second part of this is for you to pick an order pair. Pick 220, 415, 8, and 5. Pick. I hope you picked the easiest one. And the easiest one, actually there's no easiest one. Let's just pick this one. So let's replace x and y with 2 and 20, and then solve for b. Y is 20. -5/2 times x, which is 2, plus b. We can simplify here. This 2 and this 2 can go, becomes 1. So our actual equation is 20 equals -5 plus b. We're going to add +5 to each side. And we get that b equals 30. So now I have the slope, and I have the, I have the slope, and I have the y-intercept. So my final answer is y equals -5/2x plus 30. Something about a bus ride. So she has. Okay, so let's think about this. Make it easier in the graph. X. Hang on. Please don't turn over. Don't turn. Okay, saved by the bell. I think. I hope. So that's how much money she has. Right. The y-axis represents the money on her car. The x is the bus rides that she takes. Bus rides. So notice that she hasn't taken the bus yet, and her car is at $20. And every time she uses, and I'm gonna write 1, 2, 3, 4. Every time she uses the bus, it goes down by 2. 2, another 2, another 2, another 2, and it's a linear relationship, right? It's a straight line, but it's negative slope. So how do we write that as an equation? Well, y equals. Where does this story start? Well, it starts at 20 on the y-axis, right? Because that's the beginning. +20 because that's what her car starts with. So we can write +20. And what's happening over and over and over and over? It's going to, her slope is going down by, so her value is going down by 2 times the number of rides. And this is your equation. Okay, that's it.